All right, continuing with numbers 10 through 13, here we go. So this problem is our table and some probabilities based on that. But in particular, we're interested in, A and B, not too big of a deal. But let's look at C. Don't forget that with this C, it says Caucasian or vegetarian. So what a common problem is students will go, oh, 173 Caucasians and oh, 100 vegetarians. Well, if you do that, you have then counted that 38 twice. If you just added 173 plus 100, you counted that 38 twice. Okay. So that means that recall on your formula chart here. So let me show you again. I like to show you the whole thing here. So we're here. I want you to look in this little section for this probability section here. When we do that, if I can pull that up to show it closer in. Then right here, we have got this where we say the probability of A or B, okay, like on that problem, Caucasian or vegetarian. That's overall Caucasian probability plus the overall vegetarian probability, but subtract the overlap, the Asian, Caucasian and vegetarian that got double counted. All right, now let's review while we're here on this, that this is the given that. Okay, remember this is the given that B has happened. What's the probability that is A and B? A and B out of the total probability of B. And then the other final thing is, remember that when you are checking for independence and you are asking for that, there is a particular mathematical way to statistically give evidence of that. And so this is not on the formula chart, but this is a perfect little place for us to always memorize that that's where that goes, and we're going to put that down there. And so what we do is we look at the overall probability of event A, and then we see, oh, what's the probability of A given that B has happened? Because we want to know if the fact that B has happened, is it changing the probability of A? And that tells us if B is affecting or changing the probability. If it is changing the probability, then of course A and B are not independent because they are independent if the fact that B has happened does not change the rate. Okay, so here that's what we saw with C was that A or Caucasian or vegetarian. Here is a out of the vegetarians, this is the Asian vegetarians. And then out of everybody, Asian and vegetarians. Now, on F and G, I was asked, how was I supposed to know that we keep that person out and we need two different people? Um, and I don't know. I don't really think it's that clear here either. But what I've seen it on past exams or an AP, they would be a little clearer. Here's an example of how they did that. And my dogs are going to start barking at something. Okay, so they would say something such as this. What's the probability? We want to select two members on a committee. So what's the probability that both members on the committee are African American? Or what probability that both members on the committee neither is a vegetarian? Okay, so that would indicate to you we need two different people and not just picking the same person twice. So, in a real situation, if you are having to be assessed on that, hopefully it'd be more clear and not uh, so uh, uh, ambiguous. Okay, here we go on this. Now, here, let's not forget, very important, that the probability of at least one is all of the ways that you can have at least one person, except for the none of them. So it's 1 minus the probability that none of the four people are Caucasian. So I had to first figure out, okay, what's the probability of not being Caucasian? Well, the Caucasians would be 403. Caucasians are those 173. So this is the not So this is the not Caucasian people, okay? So the not Caucasian people are the 230. So that's how we get 1 minus the probability that um, none of the 4 are Caucasian. So at least 1. All right, let's go back to this. Here is a question about independence. You can do either of these halves. I honestly think that this side here is really more logical in real world terms because so you have to set this up with showing this statistical relationship here of an overall a marginal probability and then a conditional. So look at what I'm doing here on the right. I'm saying the fact that you're of Asian descent, is that changing the rate at which you are a vegetarian? And so when you do the math, then yes, we can see that given the fact that you are of Asian descent is increasing the probability that you are a vegetarian. Now let's talk about the things that you must include on your conclusion. Being Asian, you state, being Asian or vegetarian are not independent of each other. And then elaborate the fact that you're of Asian descent makes it more likely for you to be a vegetarian, and then give numerical statistical support. The, for example, then I put the numbers in there. Okay, you could do it this way, but this way doesn't really, in my word, I mean, I'm thinking in context makes sense. It's saying like the fact that you're a vegetarian makes it more or less likely that you're a of Asian descent. Okay, it's kind of which is the explanatory variable, keeping that in mind. Okay, that's number 10. So let's look at 11, 12, and 13. These are the multiple choices. Okay, you need to make sure that you can follow through with what's happening here. We're talking about getting a z-score, and our z-score with a sample x bar minus the mean over the standard deviation of the x bars. And that standard deviation of the x bars is that population standard deviation divided by the square root of n. Okay, so that in itself makes me be able to mark off 3 of those answer choices. Okay, then it needs, do the sample x bar minus the center of the x bars. And that's why then it's the 2 minus 2.3. Here, okay, so I want to hold off on this problem. 12, we're going to wait on because it kind of talks about this idea of bias in the estimate. And number 17 does that as well. So we're going to hold that concept for later. I feel as though just throwing it at you on this review and then expecting you to be able to produce application thought processes from that is not proper. I want to give a little mini lesson or something about this idea of bias estimations versus variability. So don't worry about that. Number 12. Here, which of the following best describes this shape? So see, look, I drew this. Like here's 4 items and 6 and 7. So here's how you visualizing it. And here's your 1 and so on. So hopefully you can see that's skewed to the right. All right. That's the end of numbers 10 through 13. The next video will start at 14.